Class with Ming. Today we talk about chain rule. That is the derivative of a composite function. You may be given a question like this: let y equal to this particular thing, and you are asked to find what is the y dash, for example. Now here, obviously, one method to do this is actually expand this thing using a binomial theorem. You're going to get many terms. That is 9 terms in all, and then take the derivative one by one. The alternative is to do the chain rule. That is, given that you have a function like this, we will let u equal to 3x plus 5, and then du dx in this case is going to be 3. Y in this case will now become u to the power of 8, and I'm going to write dy over du now. That is y with respect to u. This is using power rule, 8u to the power of 7. And the chain rule says that if this is a composite function, in this case, u here is a linear function, and y here is a polynomial, then dy dx now can be expressed as dy over du times du over dx. Now you can see that this derivative now can be treated like a fraction, where this is dy over du times du over dx. So dy over du in this case is 8u to the power of 7 times du dx is 3. So about y equal to cosine x over sine x. Well, this can be rewritten as 1 over sine x over cosine x. Now, what is this? Well, this is 1 over tangent x. 1 over tangent x can be written as tangent x raised to the power of -1. So now again, we will use let u equal to tangent x, and du dx in this case is going to be 1 over cosine square x or secant square x, and then y is equal to u to the power of -1. dy du in this case is going to be -u to the power of -2. So dy dx in this case is going to be dy over du times du over dx. dy over du is -u to the power of -2 times du dx 1 over cosine square x, or rewrite this is going to be -1 over cosine square x, and then u itself is tangent x, so it's tangent square x. So similarly, we're going to let u equal to kx, y is equal to sine u, and then du dx in this case is going to be k, dy dx in this case is going to be cosine u. Therefore, dy over dx is equal to dy over du times du over dx. So that's going to be cosine u times k. Usually this is written as k cosine u, and u itself is kx. So that's our derivative. 2 to the power of x. Now, this seems to be difficult. Basically, we need to change this using ex ln 2, right? So now if you change to ex ln 2, you can write this as ln 2 and then bracket x. That is, in another word, that this is, you can let u be our x ln 2, and then y is going to be e to the power of u. So dy du is going to be e to the power of u, and then du dx is going to be, in this case, ln 2 only, because derivative of x ln 2 is just ln 2. Therefore, dy over dx is going to be dy over du times du over dx. dy over du is e to the power of u times, and then du dx is ln2. So basically this is ln2 times e to the power of u. E to the power of u itself is e to the power of x ln2. E x to the power of ln2 itself is basically 2 to the power of x. So this is my answer. The derivative of that is just ln2, 2 to the power of x. Usually this is written as 2 to the power of x ln2. U equal to x squared, and y is going to be ln u. So dy du is going to be 1 over u, and du over dx is going to be 2x. Therefore, dy over du is equal to dy over dx is equal to dy over du times du over dx. So dy over du is 1 over u times 2x, or 2x over u itself is x squared. So you can see that the answer is that we have 2 over x.